Hi, in this lecture we are going to talk about the concrete implementation of the Tarjan strongly connected component related algorithm. So we have a vertex class with the string name, with the neighbors, predecessor as usual, we have the visited boolean flag, and what we definitely need is the lowling. This is what we have been discussing in a theoretical section. So basically that's all about the vertex class. We propagate the name from outside, we instantiate the neighbor list as an array list in order to avoid null pointer exceptions. We generate the getters and the setters for the name, for the neighbor list, for the predecessor, for the lowling, and we override the toString method and we return this.name. So let's see the Tarjan algorithm itself. The Tarjan algorithm is quite simple basically. We just have to do a simple depth first search. So the run algorithm is going to be called first, and of course we have a stack, we have a vertex list, and we store the connected components in a list of vertices. We have the time. This is going to measure the order we keep visiting the nodes or the vertices with the help of depth first search. This is not the best name, I guess, but anyway. And we have the counter. This counter is going to count at how many components do we have. So how many strongly connected components are there at the end of the algorithm. So the run method is going to iterate through all the vertices in the vertex list we have get from outside, and if we haven't visited a given vertex, we keep visiting it with the help of depth first search. So the depth first search is going to be a bit different as we have seen when we were discussing it for graph traversing. We have to set the lowling for the time and we keep incrementing it. So that's why the first node we visit, there's going to be the lowling with value 1, then 2, then 3 and so on. I made lots of comments in order to get a good grasp of how it works under the hood. We set it to be visited and we add it to the stack. Okay, we have a isComponent root. It is a boolean variable. We initialize it to be true. We iterate through all the neighbors basically and call the depth first search method in a recursive manner. And as you can see, after we have called the depth first search in a recursive manner, basically we check that if the vertex lowling is greater than the other vertex lowling, we just set the isComponent root false. So in this case we know for certain that that given vertex is not going to be the root of a strongly connected component. But after we have visited all the neighbors and the isComponent root is true, so we haven't set it to be false here basically, it means that we have found that given a vertex, so this vertex, that's going to be the root for a strongly connected component. So we just have to iterate through basically and find all the nodes and vertices that's part of the strongly connected component. So that's why we pop from the stack, this is the actual vertex, we add it to a given component, we set the lowling to the integer max value, and if the actual vertex getName is equals to the vertex getName, we break out of this infinite while loop. Why is it good? Because basically we have managed to make a cycle and we end up on the same vertex we have started. Okay, so then we add that given component to the strongly connected component list. So basically we can implement Tarjan algorithm with the help of just a few lines of code, and as you can see we don't have to make several depth first searches. We just make a single depth first search. Of course we have to modify it according to the lowlings, and of course at the end we have to check that if the component is a root, so basically this vertex, then we have to create a while loop and find all the vertices belonging to that given component. Okay, in the next video we are going to test it. Thanks for watching.